Jai Sri Ram students. In this video, we are about to start current electricity chapter. So, first of all, we will be knowing three things. What is meant by conductor, insulator, and semiconductors. Right. For this, actually, we have to do one activity as per your book. That is activity number 1. So here what you have to do, simply take one setup like this where recording is going on. Nobody should knock the door for next half an hour. So look at here, those are in this room. Take one conductor like this. Suppose this is a conductor, and connect this to a battery and connect one switch. Okay, now in between this, in suppose this area, you connect one bulb. Okay, now switch it on, and the gap here between these two, this gap, you connect one thread, and you see whether the light will glow or not. Obviously light will not glow. That means thread is not allowing the current to pass, right? So any material which do not allow the current to pass is called as insulator. So thread is one of the example of insulator. Okay, next, now instead of this thread, now you connect a copper wire and again switch it on. Now you can see the bulb is glowing. Why the bulb is glowing? Because the current can pass through this wire and can reach the bulb, and the bulb will work. So what the copper is doing is allowing the electric current to pass. Okay, so any material which allow the electric current to pass is called as conductor. Okay, clear with this? So these are very general classifications, conductor and insulators, right? Now one more classification is semiconductor. These are actually those materials, basically we don't explain about that in this activity, it is only for consideration. These are actually those materials which are not completely conductor, not completely insulator. They have some properties of conductor and some properties of insulators. Those are called as semiconductors, right? Examples for semiconductors are silicon, germanium, this all. Okay, right? And conductors, there are many examples. All metals are conductors. Okay, right? So clear about this activity? This is your activity number 1, where you will show that what is conductor, what is insulator, and what is semiconductor. Okay, clear about that? Now, after that activity 1, we will be discussing first of all about Ohm's law. See, this is one lab activity also under this topic, right? So first we'll discuss what is lab activity. First of all, you should make the circuit like this, same as we done in activity 1, right? And now you connect one iron spoke here and connect one voltmeter as well as one ammeter. Right. Now what you do, in first instance, suppose every battery is of 1.5 volt as given in the textbook. So first to connect one battery. So voltage will be 1.5 volt. At that time, obviously in this voltmeter you'll get 1.5 volt because the reading of the battery is 1.5 rating. In ammeter, imagine you are getting 0.1 ampere current. Right. Now what you do? Next you connect two batteries in series. So 1.5 plus 1.5, 3 volt will be there. Imagine ammeter is showing 0.2 ampere. Okay. Next you connect 3 batteries. So 4.5 now. 1.5, 1.5, 1.5. At this instance, imagine current is 0.3 ampere. Next fourth case, you connect 4 batteries, so 6 volt. Then 5 batteries, 7.5 volt. So in 6 volt, it's showing 0.4. In this, it's showing 0.5. Right, like this you write down all the 5, 6 readings. Now, you do V by I. In first case, 1.5 by 0.1, answer will be 15. Okay. Next case, 3 by 0.2, again answer will be 15. Next case, 4.5 by 0.3, decimal gone, 45 by 3, answer will be 15. So in every instance, answer will be 15. That means V by I is constant. Clear? Whenever we are doing V by I, we are getting the same value. This is our activity for Ohm's law. Right, here we are showing that the ratio, that is V by I, is a constant. Okay. Now, definition you have to write. See, in the diagram, if you see in the table, whenever we are increasing voltage, current is also increasing. We are increasing voltage by 1.5 volt. Current is increasing by 0.1 ampere. So proportionally it is increasing. That means voltage is directly proportional to current. This is nothing but Ohm's law. Right. How will write here? See. You should write like this. The potential difference, that is voltage, between the ends of the conductor is directly proportional to the electric current passing through the conductor at constant temperature. So voltage is directly proportional to current, but the condition is temperature should be constant. Okay? Clear about the definition and activity? Right. Now, there are two types of materials. Ohmic materials, non-ohmic materials. Right. Ohmic materials are those materials which will obey the Ohm's law. So, any material which obeys Ohm's law are called as ohmic materials. Right, somewhere it will be the definition. And non-ohmic materials are those which do not obey the Ohm's law. They won't obey Ohm's law. Okay, that means the materials which follows or obeys Ohm's law are called as ohmic materials, and the materials which do not follow or do not obey Ohm's law are called as non-ohmic materials. Okay. Now, for ohmic material, now this activity is ohmic material only because we are taking iron. Iron is a ohmic material. Okay. So for ohmic material, if you draw VI graph means on x-axis we should take voltage, on y-axis we should take current. So if you draw this VI graph for ohmic material, you will be getting a straight line passing through origin. And if you draw this for non-ohmic material, you will be getting a curvature like this. You won't get a straight line. Right. So ohmic material के लिए straight line आएगा graph. Non-ohmic material के लिए curvature आएगा. Getting with this point, right? Next, limitations. See, Ohm's law is valid only for metal conductors. The condition is temperature and other conditions should remain same. Means temperature should not vary. If temperature varies, Ohm's law is not applicable to metals also. Right. And here, see what happens when temperature varies. If temperature varies, resistance changes. If resistance changes, then current value changes. That's why temperature should not change. Okay? And Ohm's law is not applicable to gaseous conductor. It is applicable only to metal conductor. Okay? So first point is it's applicable only to metal conductor, that too at temperature remaining constant. If temperature is changing, then Ohm's law will fail there also. And Ohm's law is not applicable to gaseous conductors. Ohm's law is not applicable to semiconductors. So these three are the limitations, right? So till here you have the limitations of Ohm's law. From here this is new topic. Understood about this? So now clear about the Ohm's law, activity, Ohm's law definition, along with the activity the table, ohmic material, non-ohmic material, and the respective graph, right? And a small derivation also we'll see. This is clear, right? We'll see derivation in this. Okay, here only we'll discuss in this textbook they gave now. See here, V is directly proportional to I. So when you remove this proportionality symbol, we should write equal to. And at the same time, we should write proportionality constant. The proportionality constants here will be R. Resistance. So according to Ohm's law, V is equal to IR. Right. Where R is resistance, opposition to the flow of current. SI unit of resistance will be Ohm, in the name of this scientist. And symbol for this, you should write like this. Okay. Now, can we write the R formula? R is equal to V by I now. Right? I use on this side. Now, so we can write like this. 1 ohm is equal to 1 volt divided by 1 ampere. Ohm is the resistance, unit of resistance, volt is the unit of voltage, ampere is the unit of current. That's what they gave you. 1 ohm is equal to 1 volt by 1 ampere. That short form is this one. 1 ohm is equal to 1 volt by 1 ampere. Okay, this also you should mention. Getting with this? Within this you will get 3 questions within this one topic. Right, okay? Yeah, clear up to this? So, hope you have understood till this. Ohm's law, those all. Now, we are going to discuss about resistance, continuation. See, just now we have seen R, V is equal to IR. There R is called as resistance. Now, what is resistance? Resistance is the opposition to the flow of electrons, right? So, in a conductor, when electrons are trying to move, resistance will try to stop them, right? Because of resistance, the speed of electrons will come down. Just like because of speed breaker, vehicle speed will come down. Same way, okay? And any material which is offering resistance to the electrons, that material are called as resistor. So ऐसे कोई भी मटेरियल जो रेसिस्टेंस प्रोवाइड करेंगे उनको क्या बोलेंगे? रेसिस्टर बोलेंगे. ओके, क्लियर विथ 2 definitions, राइट? नाउ, so first we'll discuss factors on which resistance will depend. Right. Now resistance depends on 4 factors. First one is temperature. Okay. See, simple word. First you go through the activity, you can understand now. Circuit you have to make, connect the devices one by one. Right. Here the concept is whenever temperature increases, resistance also increases. Okay. Right. So how we can understand, sir? See, suppose you might have seen the tungsten bulb, Sobatti ka gola. It has very high resistance, and when current will pass through the tungsten bulb, that resistance will come out in the form of loss of heat energy. That heat energy is nothing but light energy. Now the resistance is very high, that's why tungsten bulb will also be very hot. Getting? That means if resistance increasing, temperature increasing or no? So in other words, if temperature increases, resistance also increases. Right, that's why you see tungsten bulb. After half an hour, you cannot hold it with your bare hands because it will be very hot. Getting? So relationship clear? If temperature increases, resistance also increases. Okay, overload underload condition given, that I'll explain you separately, but not necessary in this. Okay, overload underload those condition. See, next, resistance and nature of the material. See, resistance depends even on nature of the material also. See, suppose one conductor is made up of iron, one conductor is made up of copper. Both are conductors, but wires are made up of iron or copper? Basically copper, right? Even tungsten is a conductor, but does it mean we make the wire by using tungsten? If we make the wire by using tungsten, then wire will burn within few minutes, right? Tungsten is also conductor, copper is also conductor, iron is also conductor, but we use only copper as a wire. Why? Because copper will offer less resistance, iron will offer more resistance, tungsten will offer even more resistance, right? That means resistance of a conductor depends on the material by which this conductor has been made. If the conductor is of copper, resistance is less. If the conductor is made by using iron, resistance will be high. If the conductor is made by using tungsten, resistance is too much high. So here resistance is depending on nature of the material. Getting clear with this point? Next, length of conductor. See, resistance will be directly proportional to length of the conductor. Suppose you take one system like activity number 1, battery, everything you connect, and you connect one 5 centimeter rod, and next to connect 10 centimeter rod, next to connect 20 centimeter rod, next 50 centimeter. You keep on changing the length of the conductor, but diameter should remain same. When you're changing length, diameter should remain same. Then 5 centimeter rod will give, suppose, 2 ohms resistance. 10 centimeter rod may give 4 ohms. 15 centimeter may give 6 ohms. So when length is increasing, resistance is also increasing. Okay? So R is directly proportional to L. But the condition is at this time, temperature and diameter should remain constant. Area of cross section means diameter in simple words. Okay? Next, clear about that relation? Next, area of cross section. Area of cross section means diameter, you can consider. Now you take 4 copper wires. Length, let it be all 4 copper wires are of 10 centimeter only. But thickness is increasing. Okay? So when thickness is increasing, resistance will be decreasing. Why? Because suppose, imagine this is the wire, that pipe. Its thickness is this much. Then suppose we are letting the water to pass. If the same length wire, thickness is this much, then water can go easily or not? Right? Suppose there is one door, small door equal to the size of one human being. Then 100 human beings should pass. Will they feel difficult or not? If the door is of the length of our gate, then easily 100 people can pass. Means if diameter increases, it is easy to move. Right? Applicable to this thing also. If the diameter of the wire increases, resistance will decrease because it is very easy for the electrons to move. If electrons can move easily, that means resistance is decreasing. Getting? So R is inversely proportional to A. Getting with this? In that R is directly proportional to L. In this R is inversely proportional to A. That means area of cross section decreases, resistance increases. Or area of cross section increases, resistance decreases. Clear? Inversely proportional in simple words. Got with this point? Clear all of you? Resistance relation, right? चलो यहाँ तक समझ में आ गया सभी को? आगे जाते हैं रेसिस्टिविटी की तरफ. See, first of all, just now we have seen R is directly proportional to L and R is inversely proportional to A. combination of these two will give you R is directly proportional to L by A. Okay. Now, if you remove this proportionality symbol, then you will get R is equal to rho L by A. This rho is nothing but resistivity. What is it called as? Resistivity. This one more name is specific resistance. Okay. R is resistance. Rho is specific resistance or resistivity. So what is this rho? The rho is the inbuilt property of material. See, resistance depends on length, diameter, but resistivity do not depends on length or diameter. Right? Suppose I have one conductor of 10 centimeter made up of iron, one more conductor of 10 meter made up of iron. Both conductors are made up of iron, but one is 10 centimeter, one is 10 meter. If I find resistance, first one resistance will be low than the second one. First one's resistance will be low. But if I find out resistivity of both the conductor will be same because they are of same material. Right? So resistivity is the property of the material. The conductor may be 1 centimeter or 1 kilometer. If it is made up of same material, then its resistivity will remain same. That means resistivity is inbuilt property of any material. Getting? It won't change. You cut the material 100 times, then also resistivity will remain same. Diameter may change, length may change, but resistivity won't change as long as material is same. If material is changing, then obviously resistivity will change. Clear with this point? And the SI unit of resistivity will be ohm meter. How we get this? See, R is equal to rho L by A. R you keep there. A will go that side to numerator. L will come to denominator. What is the unit of R? Ohm. What is the unit of area? Meter square. Unit of length? Meter. Right. Meter and square cancel. So what we left out with? Ohm meter. This is the unit of resistivity. Ohm meter. Clear with this point? Right. So got about the resistivity. Now reciprocal of resistivity is known as conductivity. Resistivity का reciprocal लिखेंगे तो उसे क्या बोलेंगे? Conductivity. And is denoted by this symbol, conductivity. Okay? And any material whose resistivity is low, that is said to be good conductor. So ऐसा material जिसके अगर resistivity कम होगी तो उस कंडक्टर को हम क्या बोलेंगे? गुड कंडक्टर बोलेंगे. रेसिस्टिविटी ज़्यादा होगी तो उसे गुड कंडक्टर नहीं बोलेंगे. गेटिंग राइट? अब यहाँ पे बहुत सारे मटेरियल्स के आपको वैल्यू दिए गए रेसिस्टिविटी के. राइट, इनमें से कुछ याद रख लो आप लोग थोड़े से. जैसे एयर का याद रखो, ड्रिंकिंग वाटर का याद रखो, जर्मेनियम का याद रखो, सिलिकॉन का याद रखो. एक 4-5 याद रख लो जरा. टंगस्टन का, राइट, और आयरन. ये पूरे बाय डिफ़ॉल्ट फिक्स्ड वैल्यूज है. ये सब प्रैक्टिकली करे सो रहते हैं. हम उसको कुछ कर नहीं सकते, बस याद रखना पड़ेगा. गेटिंग? अब डिफरेंट रेसिस्टिविटी वैल्यूज दिए गए यहाँ पर अलग अलग मटेरियल के. राइट, रेसिस्टिविटी डेफिनेशन लिखो, 1-2 एग्जाम्पल लिखो वैल्यू के साथ. 4-5 याद रख लो, ऑब्जेक्टिव में भी काम आ जाएगा. राइट, अगर क्वेश्चन आ गया तो मिनिमम 1-2 एग्जाम्पल तो लिखना. जैसे टंगस्टन रेसिस्टिविटी 5.6 × 10⁻⁸. आयरन रेसिस्टिविटी 1.0 × 10⁻⁷. ऐसे 1-2 लिख दो एग्जाम्पल. राइट, 4-5 तो याद रखो कम से कम. क्लियर है सभी को? रेसिस्टिविटी. So this will be the part 1 of this chapter. So we are going to end it here now. So in this we have discussed the activity 1. We have discussed the complete details about the Ohm's law. We have discussed about the resistance and factors on which resistance depends, and we have discussed about the resistivity. These topics have been covered in this first part.